In this video, we will talk about Arduino general purpose input-output pins and learn to use them with hardware. Arduino pins can be configured either as an output pin for controlling devices and sending information, or as an input for reading sensors or receiving information. This configuration is done by using the pin mode function. The function has two parameters, pin number and functionality, either input or output. If you define pin mode as an output, there are two functions that you can use with pin: digital write and analog write. Digital write will output either high or low level. It can be used to control digital logic, LEDs or other low power devices. As an example, we will make a simple schematic on a breadboard with LED and control it with our Arduino digital pin. First, we will plug resistor in the breadboard. Then, we will plug longest LED lead to the side of the resistor lead. Another LED lead in the line below. One wire will connect the resistor free lead to the pin number 5. Other wire will connect the free LED lead to the ground pin. We will make the blinking LED code. In loop function, write the digital write function and as a parameter write pin number and set pin level to high to turn on the LED. Copy this line under and change high to low to turn off the LED. After each line, write a delay function to slow down blinking so that people's eye could see it. When you upload your code, you should see the blinking LED. If LED doesn't blink, check your code and electric circuit on your board. Especially look at places where you put leads of each component. Misplacing leads might lead to short circuit or no connection. Analog write outputs PWM, short for pulse width modulation. PWM is a square wave signal where the pin is either on or off. We can change how long pin is on or off by changing the duty cycle of each period. This is used to simulate an analog output, which can be used to dim LEDs, make sound output, and control motor speed. To demonstrate PWM, we will write the code that dims LED from the previous task. We will use for loop to cycle through different PWM values. In for loop brackets, we will write analog write. As a parameters, write pin number and for loop counter value. Add small delay so that dimming is visible. When you upload your code, you should see that LED becomes brighter, then turns off, and cycle repeats. You can replace LED with speaker between pin and ground, and it should make a sound. Different PWM values will give different tones. If you configure your pin as an input, you can use digital read and analog read functions. Digital read reads voltage values that correspond to either logical high or low values. In the circuit, these voltages usually are 5 and 0 volts. Mostly this is used to read buttons that can be either on or off, but many sensors also output high or low value. We will make a circuit with the button and Arduino. Then the button state will be read and printed out on the serial monitor. To make a circuit, connect one side of the button to pin 4 and another side to the ground pin. Be careful to choose correct button leads, because some button leads are connected internally, and if connected incorrectly, button won't work. In code, change pin mode to input. Because of microcontroller internal circuit, we need to preset default pin level, otherwise your readings won't be accurate. To set this level, you need to turn on an internal pull-up resistor by writing a digital write function to high. Also enable the serial monitor. In serial monitor, we will print out button value. To read value, write digital read pin number as a parameter and some delay at the end. Upload your code and turn on the serial monitor. It will show 1. If you push the button, it should change to 0. Analog read reads voltage value of the input and converts it to number between 0 and 1024. Only pins with letter A before its number has this functionality. To demonstrate analog read, we will connect photoresistor between analog pin and ground pin. We will be using an internal pull-up resistor, but you can add an external resistor between the analog pin and 5-volt pin. We will modify our button code so that it reads our sensor. First, change pin number to an analog pin number. In loop, change digital read to analog read. Upload your code and turn on the serial monitor. You should see the number printed out on the serial monitor. If you shield sensor from the light source, you should see that this number goes up. In this way, you can approximately determine the light level in the environment. More information about input-output pins can be found on the Arduino reference page. If you want to learn to use breadboard, go through suggested online tutorials.